When we have functions, there are linear and nonlinear functions. So we're going to take a look at determining which one is which, okay? First thing that you want to make sure is that when you look at a table, you're making sure that your change in your x is increasing by that same amount. Okay, so these are all increasing by 1, so we're good so far. Now I'm looking at my f of x, which is the same thing as my y values. And I say, okay, to get from -4 to -8, I have to subtract 4. To get from -8 to -12, I have to subtract 4. To get from -12 to -16, I have to subtract 4. And to get from -16 to -20, I have to subtract 4. So we would say this function is linear because it has a constant rate of change. Remember, rate of change is your change in y over change in x. So it has a constant rate of change. So now let's take a look at example B. As you can see from the x values, we are increasing by 1 every time, so that is looking good. However, when you get to those y values, you notice that you're increasing here by 22. And if you're not sure what you're increasing by, you just take the second number and subtract the first number. So 44 minus 22, then 88 minus 44, but you'll already notice that you're increasing by something different. As you continue your pattern, you see you're increasing here by 88 and then increasing by 176. And so this is non-linear because it does not have a constant rate of change. It does not have a constant rate of change. And so simply that's all you need to write to determine whether it is linear or non-linear. Okay. So now we look at a couple of Regents questions that are multiple choice. We'll look at the example on the left first that says which function is linear. So as you can see from all of these, they are going in order on the x side. So none of that really needs to be looked at. However, we do need to look at the numbers on the right side. To get from 6 to 7, I add 1. To get from 7 to 10, I add 3. So already this example is out because I don't have a constant rate of change. To get from 1 to 2, I add 1. To get from 2 to 4, I add 2. Once again, this one is already out because it does not have a constant rate of change. Now, to get from 0 to -2, I have to subtract 2. To get from -2 to -2, you just do nothing. So either you add 0 or you subtract 0, which again is out. Now, if you look at your last example, to get from 2 to 5, you add 3. 5 to 8, add 3. 8 to 11, add 3. 11 to 14, add 3. And so that's J of X, which makes this choice 4. All right, so it's important that you're just looking at your change in Y over change in X to see what is having a consistent change and which is not. Okay, which situation does not represent linear growth? So linear growth means that, like we've been talking about above, your change is constant. Okay, so I'm going to just write that on here. Change is constant. So in choice 1, it says Aiden adds $10 to a jar each week. That's constant. That's linear. Every week he's adding $10. Next one, a pine tree grows 1.5 feet per year. That's constant. Every year it's growing 1.5 feet. Number 3, Ella earns $20 per hour babysitting. That's constant. Every hour that she works, she's earning $20. However, looking at choice 4, it says the number of people majoring in computer science doubles every 5 years, okay? For example, if you start with 2, then you would jump to 4. Well, if you double 4, now you're at 8. Well, now if you double 8, now you're at 16. This is just an example, but that's not linear because the change is not constant, okay? Remember that change has to be that you're adding or subtracting to get from one number to the next, and it has the same value. So choice 4 is the answer because, again, it says which is not. So it's really important that you look out for those code words. All right, last example is very similar. This is saying which of the contexts below represents linear growth. Linear growth, okay? So choice 1 says an elevator descends at a rate of 20 feet per second. Well, You might see the 20 feet per second and say, okay, that's linear growth. However, it's saying descends. Descend means to go down. That is not growth. That is what we call decay. That is not growth, so it cannot be choice 1. Okay, anytime that you see a percentage per year, that is not linear. Percentage per year is not something that's linear because that's going to continue growing, what we call exponentially. So choices 2 and 3 are out. So we're only left with 4, but let's look and see why. A sunflower was growing at a rate of 2.5 inches per week. And so for that reason, it is linear growth. Okay, so make sure you're looking out for your change in Y and over change in X, and looking out for what is possibly doubling in growth as opposed to growing at the same rate.